And we're live. Thank you very much for showing up. We're here to talk about a window installation that you can trust. So just to kind of get an idea of who we have in the audience here, how many people here are builders? And for those of you who are builders or not, how many of you are self-performers? Are you like in the field getting the work done? Any architects, designers, engineers? So it's kind of nice to know we're going to get a little bit into the building code so that at least we're code compliant. But then we're going to see how a window actually gets installed, talk about some of the theory behind it, and hopefully it will be enjoyable. We have myself, Bryan, Uhler, Pioneer Builders, second generation builder. My dad started the company in 1978, and I came along 2 years later. And I've been running the business for, I don't know, a few years now. He's still around, but for the most part, not so much working. Then we've got Mike Cairns. Mike, tell us about yourself.
I'm with Innotech Windows and Doors, like Bryan, second generation, but in the window business. I got my start in construction in the leaky condo crisis in the Pacific Northwest. So a big, early learning experience in how devastating poor window installs can be for homeowners, and so that was very instructive, and I've been doing windows ever since.
All right, and then you might look at the board. We've got Tim Uhler. You might have heard of him, Awesome Framers. He is my older brother. When I asked him for what his title was, he couldn't come up with one, so I gave him one. He is the Mac Daddy. All right, so Timmy, maybe tell us about your history just a little bit.
Like Bryan said, Dad started the company when I was 6 months old, and we have, I think from day one, always had in-house framing, foundation siding. The carpenters used to be able to do all the flat work. Like, we did everything. So I just grew up doing this. I remember being out there troweling when I was like 12 years old. So it's just in our blood, and for me especially, being on the job site. That's where I'd rather be. I'm just getting a little old for some of it.
And like we talked about, we don't have the data on it, but maybe 1,000 windows or so, or exterior units that Timmy's been involved in. Who knows?
With like a 20% success rate.
Yeah, so we're
qualified.
1 out of 5, then that ain't bad. Okay, so let's get into the presentation a little bit. Why should we care about windows? Really, any exterior door opening. If you got to see Matt's presentation this morning, water is the #1 killer of buildings. We're all in British Columbia or Washington State, and we get a steady amount of water for a long time. It's different if you're in an area that gets wet and then dries, like say Las Vegas, a lot of water, but then it evaporates pretty quickly. If something stays wet for a long time because you don't have enough thermal energy in the air, that's when you can get rot. So if you take a look over here, we never do renovations, but we helped out with a little situation. This building was built maybe in the 80s, and you can see all of the rot that we have. This post, and then, so hopefully you're able to see that from where you're at.
And we don't want this to happen?
We don't want it. It does allow for natural ventilation. If you're really a friend of the earth and you just feel like mold has a right to live, this is the post for you. I love the thumbs up there from one of our guys. So when I first started working for Dad, I did so many callbacks. Dad did a lot of things right, but unfortunately there was things he did wrong. If I could have a shirt made, it would be I hate callbacks. So why do we want to have a good window installation? One of the main reasons is because we hate callbacks. Lawsuits are awful. And something that's concealed for a long period of time it could lead to a lawsuit or just a lot of financial issues. Mm-hmm. On the less financial side, you'll probably end up with a better energy efficient home. If you're solving for the water side, you're probably solving for the air side as well. So you'll be able to take your indoor environment, which is something we get to create, and separate it from the outside. If you just had an opaque wall surface, your ceiling, your floor, you would totally be, well, that's what we call a submarine. We're not building submarines. We do windows because we want natural light, and we need a place just in case there was ever an emergency situation where we needed to egress or a firefighter needed to ingress. we have openings so that we don't have safety issues. So we're going to talk about, you hear about how a house is a system of systems. It's the same thing when it comes to a window installation. It also is made up of a system of systems that all should work together, and hopefully as we go through this, the purposes will make sense, why we're doing it, and if you can understand that, then in your local situation, you can adjust it for your situation. So this may not be exactly how you would want to do it, but it gets us going. So we have this structure, and the red doesn't come up too terribly well. For those of you who are framers, take about a 2-minute nap. For those who aren't, and you can see it over there as well, starting from the bottom, we have the bottom plate, cripple studs, window sill, trimmer, king stud, header pocket, header sill, double top plates, and a rafter. Why do we even talk about that? Because probably the most important function of the wall is to transfer vertical loads into the foundation, ultimately into the ground. If you just have even a 24-inch on center, 2x4 wall with wall sheathing, that is a really strong wall. The wood studs are going to be on that longitudinal axis of the tree, and trees can carry a lot of weight. What ends up happening is we punch holes in our walls. So we just very briefly talk about that structural side of things as far as it being a system for how we're going to transfer all of our loads while taking into consideration some of these other factors. So that's not too deep, but what you see in the background there is that header pocket. We've got LVL headers, and if you price it out instead of full depth dimensional headers, you might be surprised. You can fill that in with insulation, and that's part of that system that we're talking about. It's not just about the window construction itself, it's the whole thing. So we're making our wall ultimately more energy efficient. The LVL studs are extremely strong, and when it comes to callbacks, if you push your LVL header to the exterior, you're probably not going to have the same window or sheetrock spidering that you might get. So that's just another little tip there if you're using engineered wood materials, wood products on the outside. Mike, maybe I'll give my voice just a little break here. This is a small window, but tell us a little bit about what happens with some of these huge lift and slides.
Sure. So one of the things that we have to account for when we're dealing with openings in the wall is the fact of building movement. No matter what, buildings are going to move. You get different shear stresses, and the biggest deal very often, particularly when you're dealing with long spans, so you do like a big 15, 16, 20 foot door opening, you're going to have deflection in the header. So when you get an engineered header, oftentimes there's a little bit of a perception that that header, because it's engineered, is going to remain pretty static, but they're actually engineered to have a certain amount of deflection, and you have to kind of account for that. So that's one of the main reasons why we have what's called a rough opening. So we have a gap around the window that gives you some room to maneuver. So as the building's moving and deflecting, you're not going to be crushing that window and changing how it sits, because then it's not going to function properly.
Did you mention, Mike, Bryan was making me second screen, why your windows are sized smaller? Did you mention that just now? Like, in other words, there's a big enough gap so that even if the header deflects a little bit, it won't affect the window.
Yes,
okay.
Exactly.
So I have a question for the audience. Is there anything wrong with this mock-up when it comes to actually framing windows? Yes. Okay, the sill's not sloped. Oh, that's something that's wrong.
Oh boy, this is going to be fun.
You might have opened a can there. Okay, so that's one.
It's not a plant, I promise.
Yeah. Anything else?
Look
The
at
architect doesn't want to weigh in?
Look at the trimmer.
So just curious, how many of you split your jack or trimmer stud with the sill? Sometimes. Okay, Joel's a future politician. Depends. Nice. Okay, why don't we generally want to do it this way? Does anybody know? Yeah, and what will always happen to wood is it's going to dry out, right? And we don't want this gap here, so where you're essentially just hanging off the nails because this doesn't actually sit on the sill, which doesn't actually sit on the cripple. So what our engineer taught us is that because, like Bryan mentioned, we're punching a hole in the wall, we still have lateral forces like the wind, not just earthquake forces. And so the window has to be strong enough to withstand that, but so does the framing around the perimeter. So he taught us, the code actually, once you get over a certain size, we're actually supposed to double up king studs. The engineer that we're working with on the current project, he specifically wrote in how many jacks and how many king studs he wanted at each window. And I was a little surprised because they weren't big windows, but he wanted double kings. But that's because maybe there was more wind loading. The other thing is, how many of you are still putting a cripple stud on the end underneath the sill? Joel, you're not doing it?
Joel, sometimes.
If it lands on layout, yes. Yeah, so like as far as the window installation, what we find is that we can take a lot of wood out of the wall without losing any structural performance, and then we gain thermal performance. So if we do the LVL header, which I think I priced that, it was like $60 for the house to go from 4x10 to all 1 3/4 by 9.5. The advantage was I can order an odd foot sizing, and it is super lightweight. You can sit there and hold the header with one hand.
Timmy's stronger than me, so he can hold it with one hand. I'm a two-hand LVL
he's
holder.
an accountant, right? But he's really good with a 10 keypad, so. So anyway, just as far as like the structural, there's, it's just good to know what the whole thing is. We're not just talking about window installation. And I think we're coming back to the sloped sill.
In just a second, ultimately, some of these windows can get extremely heavy. And these lift and slide. So you have to think about the structural side of things so that you don't get yourself in a pickle later. They've got a window here that you'll be able to take a look at. You'll see the cutaway. If you're not familiar with triple glazed windows, they can get awfully heavy in a hurry. Let's turn that around really quick just in terms of the system. So I learned years ago, structure trumps everything. All right. Another thing that we have to factor in, though, we talked a little bit earlier about the water side, and then we also have to factor in how we're doing our air sealing. All of that comes into play. It's way easier to air seal a wall without an opening than it is to have one with it. So in this case, we've got our WRB, which is the facing on the OSB panel. The OSB panel is a wood structural panel. So now we're taking care of our shear forces, we're taking care of our liquid water, and I think we should flash the opening now. So feel free to talk while you're doing it, or I'll just kind of narrate it a little bit. While he's getting ready there, this is a source that I got, Upcodes. If you want to get into the code and see exactly what's there, Upcodes to me is the best resource. You'll find what's actually been adopted in your local jurisdiction. Whether it's being enforced or not is a topic for another day, but Upcodes is really a good source. So this is a section here, R703.4.1, flashing installation at exterior window openings. It is actually in the code, and to my knowledge, it hasn't been updated in I don't know how long. If a code section hasn't been updated, there's a good chance they kind of got it figured out. So just a couple of highlighted portions here. Water resistive barrier. Air sealing shall be installed around all window and door openings on the interior side of the rough opening gap. It addresses pan flashing. And then here's my favorite part of this entire thing. In accordance with other approved methods. So keep that in your back pocket because you might be able to get something approved that isn't technically in these other code sections, but still works. So go for it, Timmy.
It's Big T.
Big T.
Are you impressed, Joel?
So maybe tell us what you're doing, Timmy.
So this is just Huber's stretch tape for the sill. And you might wonder why it's named that. I'll show you in just a moment.
While he's doing that on the picture, but keep watching him if you want, I'll keep the picture up for a while. One cost-saving method you can do is use Huber's flashing tape on the flat. It's less expensive. And then just on the corners, use the stretch tape. So in this case, Timmy just kept it simple, and he's using the stretch tape.
It's a lot easier when the wall doesn't move. So the framers. Okay, so the sill is taped, albeit, huh? You beat me to the question. What is the next step?
He also
Yeah.
called you baby. I don't know how you feel
Yes.
about that.
It's okay. We spent time at the pool together yesterday, so now we know each other quite well.
So the reason you roll the tape is because especially the zip surface has a little bit of undulations to it. This helps to allow that adhesive to fit into all of those nooks and crannies. So if you could zoom in on it, instead of it being smooth like a marble, it's going to have those ups and downs, ridges and valleys. That allows the adhesive in the product to adhere. It's adhesive, to adhere in there better.
Yeah, and for me personally, once we get over, what is this, a 4 foot? Once we're over 4 feet.
3040.
Oh yeah, because the panel's 4 foot. So I don't know, I think Kelsey's the only one I know that can flash like a 6 foot window and just make it look perfect. So a lot of times for us to save cost, we use the 6-inch tape for the sill and stretch tape for the corners. Because it's not a cheap product, but it performs really well and it's really easy to work with. So there, we saved you just a little bit of money.
Yep. And then from the inside, this is the detail Timmy was just talking about. But you can see this is the flashing tape. And then they've got the stretch tape over that. From the outside, what do we see going on here? Anybody know? This is going against so many building science people on Instagram. Anybody? We've got a face-sealed window. Yeah, so this is a window installation you can trust. Remember, we started talking about from the beginning the whole system. So we're not telling you to do this. We're not telling you not to slope your sills or use the shims. But Timmy and I have been to Initech Windows factory, and we know how they're manufactured. It's a calculated risk. So by the time we factor everything in, including air sealing, this is an extremely easy way to do it with, in my opinion, bulletproof products. So from start to finish, it's taking the whole thing into consideration.
I was impressed when we saw the tour, which I think the video is up on your YouTube channel. I think
Yes.
the tour video is. Yeah, you can watch the testing where it's just water being sprayed at the window for how long a period of time.
It's a 15-minute test.
Yeah, and so we're finding that with overhangs, we're very comfortable sealing up the bottom, face sealing.
Yeah, and same thing with the slope sill. So again, let's just say that Timmy has 1,000 windows under his belt. We've never had a leak at the windowsill. So we would be doing it differently if we had our own experience to inform it. So it's just kind of a lesson. Take what we say, digest it, and make your own decisions. We think we know what we're doing, but ultimately we're responsible for how we build our houses, and so are you.
And it depends on the cladding and it depends on the exposure.
Exactly. Are you on a lower level of a one-story building, and it's a 1920s bungalow with overhangs that are this far, and you get almost no rain? Does it really make sense? On the other hand, X, Y, and Z. So let's inspect the opening. Check the opening for dimensions. Now we'll actually watch Mike install the window.
Sure.
So
Yeah.
how many people here have ever had their rough opening not done correctly?
So many years ago, 2007, the door company was going to use Bryan's personal house as like a door hanging clinic. So invite all the local contractors. How many of those doorways do you think were the correct height?
We'll give you a guess. All of them or none of them?
You have never seen people use a Sawzall that poorly, that fast. And we're just hogging them out. Oh man, that was very embarrassing.
So Mike, what have you found?
What I have found is this opening is the correct size as the manufacturer recommends, the rough opening compared to the window heel dimension that we have. It's also pretty close to plumb and square, or plumb and level, which is not too bad for this wall that's just hanging out in the middle of nowhere here.
Yeah.
So we are ready to put a window in theory.
Should we flip that? That way they can see how it
I think
installed?
from the inside, so to speak. Now, one other comment that I didn't know, Mike came out and helped us out, a while ago. You also might want to check your wall for plane. So you're used to thinking plumb and level and making sure that you've got your diagonals. Mike, why do we want to check the plane?
So this plumb in the that exterior vertical
Perpendicular
dimension.
to the wall.
When windows and doors are designed to function when actually plumb. So particularly if you have a window or door that has a flange on it, most of the time you're just going to press that flange up against the wall and hope for the best. But if your wall is racked, if it's drastically out of plumb, it's actually going to cause functional issues with your window or door. When you're trying to close the window and the wall is racked like this, it pulls in on one corner, it doesn't pull in on the other corner. Your hardware is going to bind, you're going to have issues, it's not going to seal up properly. You can even get that extra sensation of weight. When you're trying to open it, if the wall is leaning back, you're actually kind of pushing that sash uphill. If it's an outswing casement, if it's an inswing, it's going to want to kind of fall in a little bit, and vice versa. So it's one of those things where you actually have to have it up and down within a reasonable tolerance of plumb, and that can be problematic if you have a flange on there. You say, well, what do I do with this extra ½ inch that the window's hanging out of the wall? If your framers are not perfect, we know that
Well, we never have
are.
that problem, but
Yeah.
in theory. So I think install the strap anchors, Mike. I've got them over here.
Yes.
And you know where they go much better than we do. So while he's doing that, we can talk about it a little bit, but we're in climate zone 4C. So for those who don't know, the number part of the climate zone refers to your temperature, your heating degree days, your cooling degree days. We're kind of temperate.
Do you want me to flop it?
So 1 is very
Do
hot,
you want me to flop it
7 is
flat?
very cold.
Yeah.
The number side refers to the moisture. So if you're a dry climate, if you're a humid climate, or we get to be seasonal depressive causing climate. Gray and wet.
It's only funny because it's true.
Yes, we have to laugh about it. So we've got flanged windows here. If you might choose to have an innie window, an outie window, which is what we're doing, somewhere in the middle. We typically build spec homes, and we're pretty cost conscious. In our area, this is going to work great. These are the best windows of pretty much anything you're going to find in our area, honestly. We're not going to see these when we're not going for passive house certification as far as our energy modeling and that kind of thing.
So for these, we call them a strap anchor. This attachment method is a little bit different than what you may be used to, particularly if you're used to a nail flange concept. There are a couple of manufacturers I know that are now doing like an interior style attachment method. There are some benefits to that. There's reasons for it. We don't have to get too much into that at the moment, but suffice to say, every manufacturer is going to have their own particular method for installation. There's different ways to do it. You've got spacing, placement. These ones twist into place, and we're pretty much ready to go here now that these are on there. Look at this. One man.
When half the glass is gone, it's not nearly as bad.
So an alternative would be using a suction cup. And when you're getting into the bigger windows, you're going to want to have something. Another thing that you might have to do is actually get a piece of equipment that has multiple suction cups on it with an arm to try to reduce how much hand labor you're doing. Because there's going to get to be a point where even a group of people just can't do it. So factor that into your budgeting and your logistics for how you're going to end up installing them. So this isn't a slope sill, Joel. So sorry. What is it? Sorry,
You just
not
tell me
sorry.
where to move.
All
I'm
right.
just going to check the exterior here for level. I need to bring it up a hair
So
on one
Timmy,
side. So we're shimming under the sill here.
put the window in the opening.
So this is a critical element. You need to make sure that window starts off level. That is perfect. And I'm knocking everything off. So, ooh, look at that. Spacing it out using my finger
Maybe that's
tape
actually
measure there so that it's roughly centered.
Would this For you, Timmy?
Yeah.
And there's a couple of critical places where I need to shim it.
Go ahead.
These shims are actually kind of nifty. They're
I hope I'm not hitting
they're a
the thing.
European style one. They actually kind of lock together. They're kind of, and they've got a little tail, so they're easy to put into place. And you can pull them out and put them in as needed. So I need to make sure that this thing is plumb. I need to adjust it over.
So just one thing, again, we're using the Initech window here.
I need to move it. It needs.
There's different thicknesses of the shims, and you can plug and play them together depending on what you're trying to accomplish. And I think this one,
So,
do you have enough, Mike?
yeah, I'm going to try this. Just double check it here.
It's just a demo, Mike. It doesn't have to be perfect.
That's a good point. My perfectionism is coming into play here.
Actually, whoever was the best person in the audience gets to take this home with them. So try to get it through TSA and see what they say.
So once we've got it leveled, plumbed, and we checked the wall ahead of the time, and we knew that we were okay to press it up against the wall because this wall itself is nice and plumb, then it comes time to make some attachments.
And part of the reason for the wall plane to be plumb is so that the door doesn't just slide open.
The
when
Windows operation.
Or the window, yeah.
Yeah. And what you'll find, sometimes your windows might ghost open, and you check everything, and it's like the frame is plumb and level. Everything seems to make sense. It could be that there's a delta in pressure from the outside to the inside. So you're actually having wind pushing that window open. Typically, these windows aren't even designed to be turned into the house. You'll see the operation in a second. They're primarily designed to be tilted. The turn part mostly comes into play when you want to wash your windows, which is kind of nice to be on the inside of your house and be able to do your cleaning.
Not with these. No.
Not on this particular install. Now, if you were going to do an alternate installation method where you're doing a rod and caulk seal on the interior, you would actually want to start out with a bead, small bead in behind these strap anchors, so you have continuous adhesion when you do your main bead down there. So there will always be little differences depending on the specific methodology of the manufacturer, and it's, you know, they can usually give you some tips and tricks.
And these straps have basically breakaways. So this would work for a 5.5 inch, a 2x6, but in this case you could snap that off. And he is getting there.
One more. Oh, two more. Dang. Look at that. So these, so with those anchors in place, it's now time to check the function and double check
So
how
here's
smooth it is.
Your QA QC checking for
Yeah.
operation.
There is zero resistance at any point trying to operate it. It's nice and easy. So that window
got the, seam
is properly
right there,
installed.
too,
You can
for
actually tell just
No,
by
with
the
seam tape.
movement of the window when you try to operate it.
What is
You
this?
know that it's
Just
nice and
flashing?
Yeah.
clean. Because it's been shimmed in the correct locations,
We cannot use this.
any weight that's bearing on this, as it pulls down, it's going to push back this way. It's going to pull over at the top. So that's what these shims are preventing, that movement of the frame over time. So this is a nice, durable structural attachment over time. And then the final stage.
Well, I don't know that this frame is going to handle it. So I was going to skip it.
Well, yeah, this The wall's not going to handle
Exactly.
it, I don't think.
Yeah. So we're just going to skip that. Calling an audible here. One other comment that I would make, Mike talked a little bit about how the wood is going to move. Even during construction, hopefully your framing lumber has dried out in time. But before you put your drywall and your cladding on, depending on the phases that you're at, double check all your windows one more time, just in case you need to fix something. Something could have moved. We had one house where the roofing contractor or the roofing stalker loaded maybe literally tons of roofing onto one part of the roof instead of laying it out evenly, and it shifted the house. So things can move. In your QA, QC documentation, or if you're the guy, just double check it one more time. And
We can flip it around.
Yeah, let's flip it around real quick. As far as keeping, do you think we can even use this?
No.
All right, we will not be using this, but to finish the whole window installation, because it's one you can trust, in this case, how would you tape this off?
Whatever they tell me to do. Generally, we're going to tape the legs and then the head. So tape the vertical portions and then the head. We have confidence in Inotech, so we want to go ahead and face seal the bottom again to the stretch tape.
And so there's a couple of reasons for that. Actually, one primary reason. By having all four sides taped, I don't have to worry about detailing as meticulously the inside when it comes to air sealing. So if you've got tape over this flange, you've pretty much made an airtight window. And I know that these windows themselves, the units are airtight. So you've solved for water, you've transferred your loads, you've checked everything for operation, and you should be good to go.
And that's why we didn't slope the sill on this one, because we knew we were going to seal the bottom. So
On the job costing side, if you think in terms of how many times you do repetitive movements. So let's just say that there's 50 cripples in every house, and you have to bevel every one of those, and you have to do things just a little bit differently, and then you come in and have to do finish carpentry on top of that. All of these little steps add up, and you're welcome to do it. It's not that there's anything wrong with that, but you also might just start to go, where can I start cutting? And it's not going to impact the quality or durability of the home. It's not going to impact the people later, and it might actually be an improvement, and I can build faster. So that would be kind of the pitch for why you might want to think about doing it this way. So check our timing. We have about 9 minutes or so. Any questions or comments? Please. Even if we don't seal all sides for our company, we've never beveled a sill.
Yeah.
Even my dad's builder grade, Plygem, white vinyl windows with a U factor of 0.3, same thing. Where have we had problems with our windows when it comes to rot?
we never have. At my house, we had to swap the windows out because we were getting dripping coming from above. And I actually think that it's that half-round window
Yes.
that failed.
Yes. So,
And just for frame of reference, my house, this was what, 2001? The only flashing system on the market was Vicor, which you had to special order. Nobody flashed anything properly. You just cut the X in the house wrap, and then we started to do what, the upside down Y? So that's why I think none of my windows even have metal head flashing on the trim.
yeah.
Yeah, and they don't leak. And
that
we
came
are
in
just
later.
slammed on that one side by the weather.
And I think that's an important factor too. Not all wall assemblies are created equally necessarily, so your exposure could be different depending on if you're on the bluff of a cliff. Seabrook is a place near where we live, and it's up high, and you're going to get the wind coming in, and it's going to be driving salt water. It beats those houses up. So we might use different cladding even, just to make it more resilient.
Well, that's something I don't think we talked about, is that the choice of cladding makes a difference in all the other details. So we're generally using LP Smart Side, and things just aren't getting past that. But if we were building on Orcas Island, depending on what we were putting for cladding, we might take a different approach. So I think part of Bryan's, the point of this demo is, learn every method possible and then figure out which one is the best at that point.
Yeah, yeah. If you've ever seen Stebrick's talk that he does about how much water gets past a masonry cladding or a reservoir cladding, and he does the math on it. I don't remember exactly what it is, but say you've got a masonry wall. It's like, and it's multiple, is it wides? I'm not a mason. Anyway, coursings. That's not even the right term. It's like 1% that gets past the first part. And of that 1%, it's 1% that gets past the next part. So how much is getting through your wall assembly? It depends on how you're building, but it's important to kind of know what you're doing. Lap siding, it's basically a vertical wall, and you've got these air gaps behind it. You're welcome to do rain screens. We tend to do rain screens when you're using a panelized type product that's going to go directly up against the zip, so that we get just a little bit more of an airspace there. So we do it differently depending on what we're building when it comes to rain screens and claddings. Anything else?
I have a question for the audience. Who's your least favorite Build Show contributor? Yes, Zach, who's your least favorite? Yeah.
He's kind of
So far, that's been 100%.
Yeah. Work. Hello. Oh.
All right. Thank you guys so much. Hope you learned something. Really appreciate it.